So in the last class we have started the secondary ionization process. Okay, in the previous class we have started the secondary ionization process. So in the secondary ionization process, what is secondary ionization process? Ionization because of the ions, and ionization because of the photons. So these two and few more will come under secondary ionization. So what the point is, ionization is initiated because of the collision process. Okay, because of the collision process and because of photoionization. So ionization will take place because of these two. Okay, ionization is initiated because of the first one, that is ionization because of collision, and second thing is photoionization. And next, secondary ionization will sustain. So the ionization, the electric discharge will sustain because of the secondary ionization. Okay, so first ionization because of collision. So ionization because of collision and ionization because of radiation will create the ionization process, and afterwards the discharge will be sustained. Ante sustain ante maintain avatam, additional electrons will be created because of the secondary ionization process. So secondary ionization lo kuda few more there are few more points, so we'll see them. So the secondary ionization process will sustain the discharge process. Will sustain ante maintain చేస్తుంది ఇది, అంటే few more additional electrons apply చేసేసి it will maintain the discharge or ionization process. Okay, so in that the first one, so secondary ionization is our present today's topic. Okay, secondary ionization process is our today's topic. So previously we have seen electron emission due to photoion impact. So electron emission due to positive ion impact, this we have completed already, I think. Okay, so this is because due to ionization, electrons and positive ions are created, and again these positive ions will collide with the cathode. So I think you might remember the circuit diagram. Anode, cathode plates, those are supplied by high voltage source. So these positive ions whichever are formed, so the secondary these ions which are formed, so these ions which are formed will collide with the cathode the moment. Okay, electron emission due to positive. So this is what we have seen in the previous class. So again we have seen a new term here, gamma I, which is called as Townsend's secondary ionization coefficient. So gamma I means what? So it is like number of electrons released by per unit positive ion impact. So a positive ion impact అయితే in number of electrons release అయితే దాన్ని మనం we call it as gamma I, Townsend's secondary ionization coefficient. So it is called as secondary ionization coefficient. So if you see here, gamma is called as a secondary Townsend's secondary ionization coefficient. Why it is called as secondary ionization means there is one more a primary ionization coefficient. We'll see that again. So one more constant you will get. So gamma is called as the Townsend's secondary ionization coefficient due to positive ion. So gamma is defined as net yield of electrons per incident positive ion. So if you look at the first point, gamma is defined as net yield of electrons per incident positive ion. That means for an incident positive ion, how many electrons are released? That is gamma I. Townsend's secondary ionization coefficient. You keep that in mind. Later on we will get these things. So later on we will be discussing Townsend's theory. Okay. So in that you will be getting all these things. So Townsend's second gamma I is called as Townsend's secondary ionization coefficient. Okay. Next, this is electron emission due to photons. Okay, next slide is electron emission due to photons. This we have already seen. So whenever photons, whenever these atoms will absorb UV light, that will release electrons. So if you look at the first point, to cause an electron to escape from a metal, it should be given enough energy to overcome the surface potential. Okay. The energy can be supplied in the form of photon of UV light of suitable frequency. So again, this is energy emission or electron emission because of the photons. This also we have seen previously. So again, we can compare with falling of radiation. So if at all radiation falls on the metal plate, that is cathode, electron will get released. So that is the point. Okay, and we have got the equation H into V is greater than or equal to psi. So where H is Planck's constant, V is frequency radiation is greater than or equal to psi. Psi is the Planck's constant. Sorry, psi is the work function of the metal. Psi is the work function of the metal. So this topic we have already seen previously, and this is an example. For psi is equal to 4.5 electron volts, lambda is equal to 2755 angstroms. Okay, that is the point. Metastable neutral atoms. So electron emission due to metastable neutral atoms and neutral atoms. So what is meant by these metastable atoms? So if you see the first point, see generally metastable atoms will have more lifetime. Okay. Okay, if you look at the first point, a metastable atom or molecule is an excited particle whose lifetime is very large. That is nearly 10 power minus 3 seconds compared to the lifetime of an ordinary particle, that is 10 power minus 8 seconds. So what is this metastable atom? See how here ionization takes place because of the metastable atom. First we will see what is meant by metastable atom. So metastable atom means it is an excited atom or it is an ion. An ion which is having a lifetime of 10 power minus 3 seconds is called as a metastable atom. So the point is, again, if you imagine the diagram, just a moment. So if you metastable atom means it has more lifetime. If you see the first point, a metastable atom or molecule is an excited particle whose lifetime is very large. So it's an excited particle. Metastable atom means it's an excited particle. That means it is an ion whose lifetime is very large. That is 10 power minus 3 seconds compared to the lifetime of an ordinary particle, which is 10 power minus 8 seconds. Okay. So an ordinary particle will have a lifetime of 10 power minus 8 seconds. So which is very, very less. And whereas a metastable atom will have a lifetime of 10 power minus 3 seconds, which is comparatively large. For suppose, again, if you try to remember the diagram, a cathode and anode, all these things. So for suppose in between, if a metastable atom is formed, okay, in between, I'll try to explain it by the diagram. For suppose if you see, if this is a cathode and if this is anode, so because of collision process, for suppose an ion is formed here, an ion is formed here. For suppose it is a metastable atom, so it will have more lifetime. That means it has to reach here. It has to reach here to create an ionization. So this metastable atom has to reach from this place to this place to create one more to liberate one more electron. So a metastable atom will have more lifetimes. That is this 10 power minus 3 seconds. So this will reach this cathode and it will bombard with this cathode and it will cause liberation of an electron. Okay. For suppose if it is an ordinary atom, for suppose if it is an ordinary particle, so this will have very much less lifetime. So it will be in the form of atom for a very short time, that is 10 power minus 8 seconds, which is less. So by the time it reaches here, it will lose its energy. Okay, so that particle will become again neutral atom, something like that. It may recombine, it may become neutral atom, or it may lose its energy, whatever may happen. So for the in the process of ionization, this metastable atom plays one more role. So generally a metastable atom is, it has a more lifetime, that is 10 power minus 3 seconds compared to the lifetime of ordinary particle, which is 10 power minus 8 seconds. Okay, so this is one way of collision. So when this metastable atom is nothing but an ion which is having more lifetime. So when this metastable atom comes from this place to and this place, and if it collides with the cathode, okay, so if that collision has sufficient energy, that means for the ionization process again in this manner, this metastable atom should have, okay, a sufficient energy and sufficient kinetic energy. So this metastable atom should have sufficient ionization energy and sufficient kinetic energy. So if this sum of these two energies is greater than the work function of the metal, then only ionization will take place. Then only that collision will create one more electron. So that is in case of this collision ionization because of the metastable atoms. And also these neutral atoms sometimes can also take part in ionization process. How? For suppose a neutral particle is here, okay, if it is having sufficient kinetic energy and if it collides with the cathode, that impact may also create ionization. That impact may also cause release of electron. Okay, in that way also ionization may take place. So that is one more way of ionization. So here the point is, here electron emission, see here electron may get emitted because of the metastable as well as neutral atoms. Metastable atom means what? Metastable atom means it is an ion which is having more lifetime, that is 10 power minus 3 seconds. Ordinary particles will have less lifetime, that is 10 power minus 8 seconds. So simply the point is, so for suppose if you సింపుల్గా చెప్పాలంటే మెటాస్టేబుల్ ఆటమ్ అనేది ఒక అయాన్. సో దానికి ఎక్కువ లైఫ్ టైం ఉంటుంది. ఎక్కువ లైఫ్ టైం అంటే మీనింగ్ ఏంటంటే క్యాథోడ్ యానోడ్ ఉన్నాయి అనుకోండి, టేప్ 2 ప్లేట్స్, ఓకే, ఇక క్యాథోడ్ యానోడ్ ఉన్నాయి అనుకోండి. సో ఇక్కడ ఒక అయాన్ ఉంది, మెటాస్టేబుల్ అయాన్. సో ఇది ఇక్కడ నుంచి ఇక్కడికి వచ్చే అంతవరకు అది ఉండగలగాలి. అంటే ఇట్ మే అండర్గో రీకాంబినేషన్ అండ్ ఇట్ మే బికమ్ ఏ న్యూట్రల్ ఆటమ్. సో అలా కాకుండా ఇట్ షుడ్ బి లైక్ అన్ అయాన్ ఫర్ మోర్ టైమ్. సో ఇక్కడ నుంచి ఇక్కడికి వచ్చి కొలైడ్ అయ్యేదాకా అయాన్ లాగానే ఉందనుకోండి, దెన్ దిస్ ఇంపాక్ట్, సో ఈ మెటాస్టేబుల్ ఆటమ్ వచ్చేసి ఈ క్యాథోడ్ని ఢీకొంటుంది కదా, అప్పుడు ఒక ఎలక్ట్రాన్ అనేది రిలీజ్ అయింది. ఓకే, అదే నార్మల్ ఆర్డినరీ అయాన్స్ అనుకోండి, సో దే వోంట్ హ్యావ్ మచ్ లైఫ్ టైమ్. సో అది ఇక్కడ నుంచి ఇక్కడికి వచ్చేసరికి అవి ఇట్ బికమ్స్ న్యూట్రలైజ్. ఓకే, అది సో ఇన్ దట్ వే it may cause electrons to liberate. One more case is because of collision because of neutral atoms. So there may be a neutral atom here, okay, so that neutral atom may collide with the cathode, which may cause release of one more electron. So these are the two cases. So if you look at the points, first point, see the first point, a metastable atom or molecule is an excited particle. That means it's an ion whose lifetime is very large, that is 10 power minus 3 seconds, compared to the lifetime of an ordinary particle, that is 10 power minus 3 seconds. Okay, so we'll move on to next slide. So looking at the first point, electrons can be ejected from the metal surface. Electrons can be ejected from the metal surface by the impact of excited metastable atoms, provided that their total kinetic energy is sufficient to overcome the work function. So if the metastable atom has sufficient kinetic energy and if it gets collided with the cathode, then if it has sufficient kinetic energy, then an electron will be liberated. So that is the point. If you see an example, so excited helium atom with a clean surface of molybdenum, nickel or magnesium cathode. So these are the materials that are used for electrodes. So these are the materials that are used for electrodes. You know, helium is a gaseous molecule. So here whenever an excited helium atom gets collided with a clean surface of molybdenum, nickel or magnesium, then it may cause liberation of an electron. So that is one example. And one more point, if you see neutral atom in the ground state, so neutral atom means what? It don't have any special charge. I mean, it is not a ion. So neutral atom has equal number of electrons and protons. So neutral atom in the ground state also gives rise to secondary electron emission. So if their kinetic energy is high, that is 1000 electron volts. So in some cases, neutral atoms can also gives rise to electrons. That is if it has sufficient energy. So which is approximately equal to 1000 electron volts. So till now we have seen only electrons and ions participating in ionization and collision process. But there is one more possibility, that is neutral atom can also create liberation of electrons. So which may take part in conduction. So that is if it is having sufficient kinetic energy. So if a neutral atom has sufficient kinetic energy and if it collides with cathode, then it may cause liberation of an electron. But provided that neutral atom should have a kinetic energy of nearly 1000 electron volts. So that is one point. And at low energies, the yield is considerably less. So if the energy is less, then there won't be any liberation of electrons. That is one more point. So that is the topic of electron emission due to metastable and neutral atoms. So just to summarize, metastable atom means it is an ion which is having more lifetime. It is an excited particle, means it is an ion which is having more lifetime of 10 power minus 3 seconds. So if this metastable atom has sufficient energy and if it collides with the cathode, it will cause release of electron. So that is one point. Okay. And again, if a neutral atom which is having sufficient energy, that is 1000 electron volts, if it collides with a cathode, then also it causes release of an electron. So that is one more point. So these are the two ways by means of which electrons can be emitted. So that is the third case in case of secondary ionization. So we are discussing about ionization process. In that, secondary ionization is one more point. In that, the third one is electron emission due to metastable and neutral atoms. So first one is secondary ionization. Second one is electrons due to photons. Third one is electron emission due to metastable and neutral atoms. Okay. Any doubts in this? So again, this is the one more fourth one. This comes under one more fourth point, that is secondary ionization, electron attachment process. So little bit this is a one more process. This is a bit different. So electron attachment process. So what is meant by an electron attachment process? See, the point is some insulating gases, some atoms present in the insulating gases will have electron affinity. Affinity means like kind of affection or attraction, something like that. So some insulating gases will have a property called as electron affinity. So what they will do is they have vacant, so they have vacancy in the outermost orbits for electrons. So they can simply saying they can absorb the electrons. So in the electron attachment process, so there's insulating gases like SF6. Okay, there are some examples shown here. So they have some electron affinity. Electron affinity means they have some affection or attraction towards electron. So simply saying they have vacancy in the outermost orbits. So those gases will absorb electrons. Simply speaking, like a sponge or so, they will absorb electrons. Okay, this is one of the important property for electrical engineers. Okay, because in case of circuit breakers, if you can recall, circuit breaker is a device which will open circuit a circuit under faulty conditions. For suppose if there is any fault means what? If there is any short circuit or any transmission line falling on the earth. So what happens is high currents will flow through the transmission line that will damage the transformer and generator. Okay. So within 10 minutes session will close. You please log in again. Just a moment. Okay. See, are you able to see the screen? See, students should be on time. See, you should be on time. There are some latecomers. I cannot assure attendance if you come late. So, electron attachment process. So, electron attachment process. Can you hear me, all of you? See, is the voice audible? Okay, thank you. See, one more thing is electron attachment process. See, I said already. See, insulating gases will possess this property. So, not all the gases, only insulating gases will possess this property. The meaning is these gases will have affinity. I said affinity means attraction or affection towards electrons. So, electron affinity. So, these gases have the property of absorbing electrons, just like a sponge absorbs water. This also will absorb electrons. Like in circuit breaker, I said, so when a circuit, to break a circuit, the moving contact will open separate from the fixed contact. So when it separates, because of the ionization process, all these things, arc will get developed. Arc means what? Arc or spark means nothing but these are electrons. Okay, arc or spark means they are electrons. So in the circuit breaker, it is filled with some insulating gases like SF6. The popular gas is sulfur hexafluoride. It is very popular. Okay, so we have already got remaining gases as well, but it is very popular. So this particular gas will absorb all the electrons. Okay, so if a gas absorbs all the electrons, what happens? The arc will quench quickly. So it helps in quenching the arc. That is the thing. So that is meant by electron attachment process. So in these gases also breakdown will occur, but as if now we are going to study only what is meant by electron affinity, all these things. Breakdown process will be discussed later. So what the point is, simply speaking, these insulating gases will have electron affinity property. So they will absorb the electrons present in the arc, thereby the arc gets extinguished quickly. Extinguish means ఆరిపోవటం. ఆర్క్ అనేది త్వరగా ఆరిపోయింది, దాని ద్వారా త్వరగా కరెంట్ అనేది జీరో అయిపోయింది. ఆల్ ద ఎక్విప్మెంట్స్ విల్ బి ప్రొటెక్టెడ్. దట్ ఈస్ ద మీనింగ్. ఓకే, సో మొన్న అక్కడ వాట్ యు కాల్ శ్రీశైలంలో ఆర్క్ ఇవన్నీ జరిగినాయి. సో దే హ్యావ్ ట్రై టు ఐసోలేట్ ద సర్క్యూటెడ్ ఫ్రమ్ అవుట్ సైడ్. బయట నుంచి వాళ్ళు సర్క్యూట్ని ఐసోలేట్ చేయడానికి ట్రై చేశారు, బట్ అది కూడా కుదరలే. అందుకని ఆర్క్ అనేది అక్కడ పెంచవలే, అందుకే పొగ చాలా వచ్చేసింది. ఓకే, సో ఆర్క్ అనేది ఎంత తొందరగా ఆరిపోతే అంత మంచిది. ఓకే, లుకింగ్ ఎట్ ద పాయింట్స్. So if you see the first point, the type of collisions in which electrons may become attached to atoms or molecules to form negative ions is called as attachment collisions. Okay, so it is also kind of collision. So electron attachment is also kind of collision process in which electrons may become attached. So electrons may become attached to atoms or molecules. So electron may become attached to atoms or molecule to form negative ions. So obviously if an ion absorbs electron, okay, what happens? It becomes a negative ion. So this electron attachment process is also a kind of collision process in which electrons gets attached to atoms or molecules to form negative ions. So this is called as attachment collisions. So this is called as attachment collisions. So we call it as attachment collisions. Next, electron attachment process depends on the energy of electrons. So again, this electron attachment process depends on the energy of electrons and the nature of gas. So again, since two particles are participating here, one electron and insulating gas. So again, this attachment process depends on the energy of the electron and also nature of the gas. సో ఆబ్వియస్గా ఏ టూ ఫ్యాక్టర్స్ అయితే పార్టిసిపేట్ చేస్తున్నాయో ఆ రెండింటి మీద ఆ ప్రాసెస్ అనేది డిపెండ్ అయ్యి ఉంటుంది. ఓకే, దట్ ఈస్ ద పాయింట్. సో దిస్ ఎలక్ట్రాన్ అటాచ్మెంట్ ప్రాసెస్ డిపెండ్స్ ఆన్ ద energy possessed by the electron as well as the type of gas or the nature of gas. So these are the examples, some of the examples. So if the session closes, you take some 5 minutes break and rejoin. Take some 5 minutes break and rejoin. Don't take much time. See, latecomers will not be given attendance. So these are the some of the examples of the insulating gases. So what are they? All electrically insulating gases. Okay, all electrically insulating gases will have this electron attachment process. So what are they? So oxygen. So oxygen is flammable. That means it will catch fire, but electrically it is insulating. So it is. We'll discuss it regarding oxygen later. So oxygen, carbon dioxide, CO2, Cl2, chlorine, F2, C2, F6, C3, F8. So these are the few more insulating gases. CCl2, F2. This is a freon, and SF6 is this is popular. So we have got SF6 circuit breakers. So among all the insulating gases, the popular one is SF6 sulfur hexafluoride, and also in some cases they will mix the nitrogen also. So all these exhibit the electron affinity property. So electron affinity or electron attachment means what? So it will absorb the, what do you call, electrons. They will absorb the electrons. That is the meaning. Okay. So simply talking, electron attachment means these insulating gases will absorb the okay. This is the electron attachment process in the form of equation. Atom plus electron plus energy. K is the energy, kinetic energy. Okay. So atom plus electron plus kinetic energy gives rise to a negative atomic ion. So whenever electron attaches to an atom, it becomes a negative ion. So negative atomic ion plus A is electron affinity plus K plus K. So K is again some energy. So this is the electron attachment process in the form of equation. So an atom plus electron plus kinetic energy gives rise to a negative atomic ion plus electron affinity. EA is electron affinity. That is the property of the gas plus K. That is again kinetic energy. So if you look at the point, the energy liberated as a result of this process is the kinetic energy K plus the electron affinity EA. So when the electron gets attached with the insulating gas, the atom will become a negative ion, plus some amount of kinetic energy is released as well as electron affinity EA is formed. So moving on to next point. So in the attaching or insulating gases, so insulating gases are also called as attaching gases. This point you can keep in mind. Insulating gases are also called as attaching gases, electron attachment process. So these are also called as attaching gases. So the atoms or molecules have vacancies in their outermost shells and therefore have affinity for electrons. So for these insulating gases, what the point is, okay, for these insulating gases, they have vacancies. So they have vacancies in their outermost orbit. They have vacancies in their outermost orbit. So they have vacancies in their outermost shells, outermost orbits, and therefore they can accommodate an electron. So they have affinity. Affinity means attraction towards electrons. So since they have vacancy in their outermost shells or orbits, they have attraction or affinity towards electrons. Okay. So especially these insulating gases have that property. So SF6 like kind of gases. And this is the equation form: atom plus electron plus kinetic energy gives rise to negative atomic ion plus EA, electron affinity, plus K. And again, so this is one of the important property for an insulating gas. So for our electrical engineers, this is a very useful point. Okay, so you are supposed to be in time. So that attachment process plays a very important role. So this attachment process plays a very important role in the removal of free electrons from an ionized gas when the arc interruption occurs in the gas insulated switchgear. So switchgear means that circuit breaker is an example of switchgear. Circuit breaker is an example of switchgear. Okay, circuit breaker is an example of switchgear. Okay, all the switchgear equipments are called as all the circuit breakers are called as switchgear equipments. So they are meant for protecting the circuit. So in the power system, what are the equipments that are useful for protection? They are called as switchgear equipments, like relays and circuit breakers, isolators. These are switchgear equipments. Okay. Okay, this electron attachment process is very useful in especially in the circuit breakers. So I have already said, so whenever a fixed contact separates from a moving contact, arc structs between the fixed contact and moving contact. Okay, this arc is nothing but electrons. So this arc is formed because of the electrons. Whenever electrons jump in air, that is seen in the form of arc. Okay, or spark. Okay, the big size of a spark is called as arc. Spark is some small one, arc is some big size. Okay, so that arc is nothing but electrons. So the quicker you absorb the electrons, the quicker you can interrupt the arc. So ఎంత త్వరగా మీరు ఎలక్ట్రాన్స్ అబ్జార్బ్ చేసుకోగలిగితే అంత త్వరగా మీరు ఆర్క్ అనేది ఇంటరప్ట్ చేయగలుగుతారు. సో దట్ ఈస్ ద మీనింగ్. So whenever in a circuit breaker, whenever fixed contact separates from moving contact, arc is struck between the two contacts. So at that time they will actually the circuit breaker is filled with the insulating gas. The circuit breaker is filled with the insulating gas. So that insulating gas like SF6 will absorb the electrons from the arc. Thereby if electrons are absorbed, then there won't be any arc because arc is formed by electrons. So if all the electrons are absorbed, the arc will quench quickly. Quenching means ఆరిపోవటం. సో quench అంటే ఆరిపోవటాన్ని quenching అంటాం. సో ఆర్క్ అనేది త్వరగా పోయిద్ది అనమాట. Okay, that is what happens in the circuit breaker. So this is one of the very important property of insulating gases. Okay, so this is the end of this ionization process. So till now we have seen what ionization because of collisions, first one. Next one is photoionization. Next one is the secondary ionization. So in the secondary ionization we have seen the impact of positive ions. So electrons because of the positive ions, impact of positive ions on cathode. The next one is the release of electrons because of the what photons. Next third one is because of the metastable electrons release because of the metastable and neutral atoms. The next one is electron attachment process. So all this comes under ionization. So ionization process. So are there any doubts in this topic till now? Simply ionization means release of atoms and ions. That is the thing. So these are different types of ionizations. సో ఏమైనా డౌట్స్ ఏమైనా ఉన్నాయా? సో ఒకసారి మీరు చూడండి, ఈ ప్రాసెస్ అన్నీ చూడండి, అయనైజేషన్ ప్రాసెస్ ఇవన్నీ ఒకసారి చూడండి. పీపీటీస్ నేను ఆల్రెడీ పెట్టాను కదా, మళ్ళీ ఇవాళది మళ్ళీ మీకు పోస్ట్ చేస్తాను. ఆ పీపీటీస్ అన్నీ చూడండి. మీరు ఏమైనా డౌట్స్ ఉంటే అడగండి. Okay, we will move on to next topic, one of the important one. So we have two kinds of theories that will explain the breakdown in gases. So we have two kind of theories that will explain the breakdown in gases. One is the Townsend's current growth equation. Okay, next one is what? Streamer's theory. So these are the two theories that explain the breakdown process in gases. So first one is Townsend's current growth equation. Okay, so we have got in this theory only there are two parts. because of secondary ionization also we have got one more thing. So Townsend's current growth equation, the first one. So this is a small derivation, I'll be explaining you. So this diagram you remember, I think. Okay, need not explain it again. So it has got what? It has a cathode, anode, and this is a high voltage adjustable source. This is an ammeter, current limiting resistor. So this is the gap between the cathode and anode. Here gas gets filled, so here ionization process takes place. So the ionization process takes place between cathode and anode. So here arc strikes. So whatever the electrical discharge or arc will be set up, that will be happening here. Okay. Constant current growth equation. So we'll be seeing the basic conditions. We'll be seeing the introduction of this, not a total derivation. We'll see the introduction of this derivation. So what are the various initial conditions that are there? All these things we'll see here. Okay, again this is the basic circuit diagram that is involved. So moving on to the next slide. So for suppose we'll discuss some points here. For suppose n naught number of electrons. For suppose n naught number of electrons are created here. So look at this diagram. For suppose so this is your cathode negative electrode and this is a anode positive electrode supplied with a high voltage source. So obviously I have skipped here ammeter and current limiting resistor. They will be there. For simplicity I have skipped it. So d is the distance between the two plates. Small d is the distance between the two electrodes. So here whatever the gas is there, that will be there between the cathode and anode. So gas will be present between cathode and anode. So we will be observing the ionization process and increase in current, all these things here. And here n naught, small n naught is the initial number of electrons. So here n naught is the number of electrons near cathode. So this may be formed because of the fall of see, I said to initiate the ionization process, initially we have to use ultraviolet rays. So this UV light is made to fall on the cathode. So that will cause a release of some initial electrons. So here n naught is the number of initial electrons. Okay, n naught is the number of initial electrons. So that are there near cathode. So at a distance x we are going to analyze. So at a distance x we are going to analyze. So what happens is this n electrons, when they move, they will collide with a lot of atoms here. So this gap is filled with gas is found with atoms. So when this n naught electrons moves, they will collide with the atoms in this region. Okay, so what happens whenever an atom collides whenever an electron collides with an atom, it will release one more electron. So those two electrons will collide with two more atoms, they will release two more. So those four will collide with four. So 4 and 4 will cause 8. So 8 will collide with 8 more. So they will release 16. Likewise, this electron number will multiply. So there will be lot of collisions in less time, and there will be lot of electrons are available. So initially this n naught number of electrons will travel a distance of x and they will become nx. So nx is the n suffix x. Nx is the number of electrons present at a distance x. So nx is the number of electrons present at a distance x. Okay, so nx is the number of electrons. So we'll analyze for a small distance dx. Dx is the some differential distance dx. Okay, dx is some small distance dx. So if this nx electrons move a small distance dx, then what happens? That is our analysis. So we'll try to get an equation at this time. So what is our situation here? So cathode and anode, these two are separated by distance d. N naught are the initial number of electrons. So these N naught, as they move, they will collide with the atoms in the in their journey, and they will become nx. So initial గా ఒక 100 electrons ఉన్నాయి అనుకోండి, ఇక్కడ కూడా 100 ఉండవుగా. These 100 will collide with 100 more atoms, and they will release 100 more electrons. Again this 100 plus 100, 200 will collide with 200 more electrons, that will release 400. Again 400 will collide with 400 more, and again they will release 800. So likewise the electrons number will increase as they move. So n naught is the initial number of electrons at x is equal to 0. At x is equal to 0, n naught is the initial number of electrons. As they travel distance x, they will become nx number of electrons. They will become nx number of electrons. Okay. So we'll move on to the points. So if you look at the first point, see here. Let us assume that n naught electrons are emitted from the cathode. So initially there are n naught number of electrons which are emitted from the cathode. So initial number of electrons are n naught number of electrons. So next point, if you see the second point, when electron collide with a neutral particle, a positive ion and an electron are formed. So when an electron collides with a neutral particle, so it will create a positive ion and an electron, both are formed. So this process is called as what? Ionization. So ionization by collision. So ionization by collision, or ionizing collision. So ionizing collision. So this point we have already know. Next, if you see the third point, let alpha, so there is a new term we are introducing here. Let alpha be the average number of ionizing collisions made by an electron per centimeter travel in the direction of field. Okay, if you understand, let alpha be the average number of ionizing collisions. So alpha is the average number of ionizing collisions made by electron per centimeter travel. So when it travels, so simply you can remember it as alpha is the average number of ionizing collisions made by an electron per centimeter travel. Okay, alpha is the average number of ionizing collisions made by an electron per centimeter travel, okay, in the direction of field. Okay, alpha depends on what? So alpha depends on gas pressure free, and also it depends on the ratio E by P. E is the electric field, E by P, P is the pressure. So alpha has got a name. Alpha is called as Townsend's first ionization coefficient. So alpha is called as Townsend's first ionization coefficient. Okay, so alpha is nothing but average number of ionizing collisions made by an electron, okay, during its travel per centimeter. So average number of ionizing collisions. So you can keep this in mind. So alpha means what? Alpha is the average number of ionizing collisions. So you keep this in mind. Alpha is called as what? Townsend's first ionization coefficient. So alpha has got a name. Alpha is called as Townsend's first ionization coefficient. Okay, and its name, so a concept point of view, it is average number of ionizing collisions. So it is average number of ionizing collisions. So alpha is called as Townsend's first ionization coefficient. Okay, moving on to the next slide. So at a distance x, so at any distance x from the cathode, let the number of electrons be nx. Okay, at any distance x from the cathode, let number of electrons be n naught. Initially there are n naught number of electrons. So after few collisions, after traveling distance x, they will become nx. Okay, they will increase. No, initially if there are 100, after traveling some 1 centimeter or so, it will become some 1000 or 10,000. So when these nx electrons travel a further distance of dx, so here dx is a small distance. So differential distance, dx is a small distance, maybe very less. Okay, less than 1 mm or so, less than, it can be a small differential distance. Okay, when nx electrons travel a further distance or dx, they give rise to alpha nx dx. Okay, so when these nx electrons, if they travel a small distance dx, they will become what? Alpha nx dx. So alpha is called as what? Alpha is called as Townsend's first ionization coefficient. Simply, it is the average number of collisions made by an electron. Nx is number of electrons at a distance x. Dx is the differential distance traveled. Differential distance means a small distance. Differential distance means a small distance traveled by nx electrons. So this is the number of electrons after the travel dx distance. So if you multiply few terms, we'll get this thing. Alpha is the average number of collisions made by an electron. Nx is the number of electrons at a distance x, and again dx is a small distance. So and again at x is equal to 0, nx is equal to n naught. This is the initial condition. This is called as what? This is called as initial condition. At x is equal to 0, next number of electrons is equal to n naught. Ante kada. So if this is if you can get this. So if this is a cathode and this is anode, so here, so at this point now the number of electrons are n naught. Okay, so that is what this, at x is equal to 0, nx is equal to n naught. If they travel some x distance, it will become nx. If they travel some x distance, it will become nx. So that is the point. So this is the scenario for starting our derivation. So this is the diagram. So this n naught is the initial number of electrons. Okay, at x is equal to 0, number of electrons are n naught. After they travel x distance, they will become nx. Further, if they travel dx amount of distance, the number of electrons are alpha nx dx. That is the thing we get. So this is the actual derivation. Okay, if you see, at x is equal to 0, nx is equal to n naught. That is the initial number of electrons at the cathode. Okay, next. So we'll take this term dnx. So this is the actual equation that is required. So this is the initial equation. dnx is the number of electrons after traveling dx distance. So after traveling dx distance, number of electrons are dnx. So that is equal to what? Alpha nx dx. Okay, next take this nx this side. So get this ns this side. Okay, bring this nx. So bring this nx to the LHS. So it becomes dnx by nx, that is equal to alpha dx. So integrating on both sides, if you integrate on both sides, it will become natural logarithm of nx. So differentiation of dnx by nx is natural logarithm of nx, ln nx, that is equal to alpha x plus c. So this is alpha x plus c, where c is a constant. After integration, we will get c, that c is a constant. So to get c value, you have to you have to substitute the initial conditions. So to get c value, you have to substitute the initial conditions. Initial conditions means at x is equal to 0, what is the number of electrons? So in transients, you might have studied, that is initial conditions. At t is equal to 0, what is the value? So substituting initial conditions to find c. So natural logarithm of nx is equal to alpha into, so at x is equal to 0. So this is what is called as initial condition. At x is equal to 0, nx is equal to n naught. Okay, so if you substitute ln nx is ln, so x is equal to 0 కాబట్టి ln n naught, that is equal to alpha into x is equal to 0 substitute చేయండి, 0 plus c వస్తుంది. సో ఇలా చేస్తే మనకు c వాల్యూ వస్తుంది. You will get c is equal to ln n naught. So you take this as equation 2. So already equation 1 is the first one. Substitute equation 2 in equation 1. So you'll get ln nx is equal to alpha x plus ln n naught. So మనం c వాల్యూ సబ్స్టిట్యూట్ చేసాం. ఓకే, సో నెక్స్ట్ you will get నెక్స్ట్ ఈ ln(nx) ఈ టర్మ్ని ఒక సో నేషనల్ లాగరిథం టర్మ్స్ మొత్తం ఒక వైపు తీసుకురండి. సో ln n నాట్ని ఇటు సైడ్ తీసుకొస్తే ఏమైంది, ln nx మైనస్ ln n నాట్ దట్ ఈస్ ఈక్వల్ టు ఆల్ఫా ఎక్స్. సో ఇక్కడ నెగిటివ్ సైన్ ఉంటే లాగరిథం ఏమైంది, ln nx బై n నాట్ అవుతుంది. సో ఈ నెగిటివ్ సైన్ తీసేస్తే ఏమైంది, ln nx బై n నాట్ అవుతుంది, దట్ ఈస్ ఈక్వల్ టు ఆల్ఫా ఎక్స్. సో ఫర్దర్ మూవింగ్, సో ఈ నేషనల్ లాగరిథం ఇటువైపు తీసుకొస్తే ఏమైంది, ఇఫ్ యూ బ్రింగ్ ద నేషనల్ లాగరిథం దిస్ సైడ్ దట్ బికమ్స్ వాట్, ఎక్స్పోనెన్షియల్ అవుతుంది, ఎక్స్పోనెంట్ అవుతుంది. ఓకే, సో nx బై n నాట్ ఈజ్ ఈక్వల్ టు ఈ పవర్ ఆల్ఫా ఎక్స్. సో nx ఈజ్ ఈక్వల్ టు n నాట్ ఇంటూ ఈ పవర్ ఆల్ఫా ఎక్స్ అవుతుంది. సో దీస్ ఆర్ ద నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఎట్ డిస్టెన్స్ ఎక్స్. సో at distance x these are the number of electrons. nx is equal to n naught into e power alpha x. So the number of electrons reaching anode at a distance x is equal to d. Okay, the number of electrons reaching anode at distance x is equal to d will be, so x is equal to d substitute చేస్తే we will get nd is equal to n naught into e power alpha d. So this is the actual equation, nd is equal to n naught into e power alpha d. సో మనం d distance మూవ్ అయితే n నాట్ నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఉన్నాయి కాస్త ఏమవుతుందంటే దే విల్ బికమ్ nd ఈజ్ ఈక్వల్ టు n నాట్ ఇంటూ ఈ పవర్ ఆల్ఫా డి, వేర్ nd ఈజ్ ద నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ అట్ డిస్టెన్స్ d, n నాట్ ఈజ్ ద ఇనిషియల్ నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్, ఆల్ఫా ఈజ్ ద టౌన్సెండ్స్ ఫస్ట్ అయనైజింగ్ కోఎఫిషియంట్, d ఈజ్ ద డిస్టెన్స్. సో ఈ పార్ట్ అనేది తర్వాత చూద్దాం, విల్ లీవ్ దిస్ పార్ట్, విల్ సీ ఇట్ లేటర్. సో మళ్ళీ ఇక్కడికి రండి, చివరికి వస్తే దిస్ n ఈజ్ నథింగ్ బట్ నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్. సో దాన్నే ఇన్ ద ఫార్మ్ ఆఫ్ కరెంట్ ఈక్వేషన్ రాస్తే విల్ గెట్ I ఈజ్ ఈక్వల్ టు I నాట్ ఇంటూ ఈ పవర్ ఆల్ఫా డి. సో దట్ ఈస్ ఇన్ ద ఫార్మ్ ఆఫ్ ఈక్వేషన్ I ఈజ్ ఈక్వల్ టు I నాట్ ఇంటూ ఈ పవర్ ఆల్ఫా డి. సో ఇది ఎలా వస్తుందంటే నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ అంటే నథింగ్ బట్ కరెంటే కదా, ఫ్లో ఆఫ్ ఎలక్ట్రాన్స్ ఈజ్ నథింగ్ బట్ కరెంట్. సో ఇన్ ప్లేస్ ఆఫ్ n సబ్స్టిట్యూట్ I ఈజ్ ఈక్వల్ టు I నాట్ ఇంటూ ఈ పవర్ ఆల్ఫా డి. సో వేర్ I ఈజ్ ద కరెంట్, I నాట్ ఈజ్ ద ఇనిషియల్ కరెంట్, ఈ పవర్ ఆల్ఫా డి, ఆల్ఫా ఈజ్ ద టౌన్సెండ్స్ ఫస్ట్ అయనైజింగ్ కోఎఫిషియంట్, d ఈజ్ డిస్టెన్స్ d. So this is the end of derivation. So this is the actual equation we require. I is equal to I naught into e power alpha d. Okay. Again we will see this derivation tomorrow. Rep malli ee derivation in malli explain chestanu. Okay. Any doubts till now? Derivation malli we will see tomorrow. Repati class lo malli ee derivation